पिलामाने समस्तंकु मोर चैनल फिजिक्स सूत्र विथ एसडी को स्वागत करुछि। एटा होछि मोर प्रथम वीडियो। ए वीडियो रे मु तमानंकु अपकमिंग एनुअल एग्जाम पाई इम्पोर्टेंट लॉन्ग क्वेश्चन भितर गोटे क्वेश्चन को डिराइव करिछि, जोटा बहुत शॉर्टकट मेथड रे एवं इजीएस्ट मेथड रे मु डिराइव करिछि, जोटा तमानंकु आशा करुछि इजी लागिवो एवं बुझिबा को मध्य सहज हेबो। आगामी दिन मानकरे मु तुमको अराउंड 20 लॉन्ग क्वेश्चंस एनुअल एग्जाम पाई आसुथिबा इम्पोर्टेंट 20 लॉन्ग क्वेश्चन को प्रत्येक दिन गोटे गोटे वीडियो माध्यम तुम पाखे पहुँचेबी। आशा करी तुम एंजॉय करेंगे। आसतु आम पढ़ा आज वीडियो अध्याय। स्टूडेंट्स, in this video we are discussing about the most important long type questions for CHSE as well as CBSE exam, that is called Wheatstone Bridge. Wheatstone Bridge is nothing, it is an electrical arrangement to know the resistance of an unknown resistor by using Kirchhoff's law. Kirchhoff's derived two different laws for electrical circuits, that is loop rule as well as junction rule. We are using both rules in Wheatstone Bridge, and we have to find the resistance of an unknown resistor. Whenever the question arises in CHSE or CBSE exam, derive the balanced condition of Wheatstone Bridge using Kirchhoff's law. Then after we have to write, first of all we have to write two different laws of derived by the Kirchhoff's. That is first law, that is current law, and the second one is voltage law, KCL and KVL. Then after we are going to write the Wheatstone Bridge. How to write Wheatstone Bridge? What are the necessary parts of a derivation for Wheatstone Bridge, that we are discussing in that long questions, okay, or today's video, okay. So first of all we must know, whenever write about the Wheatstone Bridge, we have to write the construction, working as well as its definition. First of all we have to write what is Wheatstone Bridge, then after its construction, then its theory or working of that Wheatstone Bridge, and finally we have to got the conclusion, okay. So first of all Wheatstone Bridge theory, first of all we have to write the definition. What is Wheatstone Bridge? Wheatstone Bridge is nothing, it is an electrical arrangement which by help of which we can find the resistance of an unknown resistor, okay. That is the definition. Then after we are discussing about the second part, that is called construction part, that is the most important part of that section. First of all we know the Wheatstone Bridge consists of 4 resistors. Out of 4 resistors we may name anything, we may name that 4 resistors. Out of 4 resistors, 2 resistors are taken as constant and known. That means we know its value and that value is constant, we can change it. The third one is variable resistor. That means we can change the value of that resistor depending upon our need. And the last one is unknown resistor. That is, unknown resistor means we have to find the resistance of that resistor. So we have to draw the electrical circuit diagram of Wheatstone Bridge. Basically the 4 resistors are connected across the 4 arms of a quadrilateral. Let here we are taking A, B, C, D is a quadrilateral. A, B, C, D having side A, B, B, C, C, D and A, D. Here we are adding the resistor R. Here we are adding the resistor P, and here we are adding the resistor Q. Here we are adding resistor S, and here we are adding the resistor R. Out of that 4 resistors, we take P and Q are constant and its value does not change and it is known, and S is variable and R is unknown. And here is a galvanometer is also connected across the diagonal BD of the electrical circuit, and the battery having potential V which supply to the electrical current to the circuit is connected across the AC of the diagonal having potential V. That means current I is flowing across the circuit due to the application of potential V. Okay, that means out of that 4 resistor we must know what is the value of R. Okay, so first of all we know here when the current I is flowing here, we know the incoming current is equal to outgoing current. That means according to Kirchhoff's first law. So if I1 is the current that flowing across the resistor P, then after the I minus I1 must be the current that flowing across the resistor R. That I1 current is flowing to the that is come to the point B, and here let Ig be the current that flowing across the galvanometer. So we may write here I1 minus Ig, that is the current across flowing the BC. that is side BC or the through the resistor Q. If we are coming to the point D, here I minus I1 and Ig both combinedly flowing the resistor what? S. That is Ig plus I minus I1. If we are adding this and this, we are getting also I. That is the current flow mechanism of the Wheatstone Bridge. Okay. Out of then after we are going to the derivation part, theory part. That means here there are two electrical loops. There are two electrical loops. Now in the electrical loop, what? A, B, D, A. A, B, D, A. What we are getting? As the current I1 and Ig are flowing in clockwise direction, that is or along the loop, that is taken as positive. If it is in the anti-clockwise direction, this is taken as negative. So we may write here, the potential is applied, so taken as 0 is equal to I1P plus IgG minus I minus I1 along the resistor R. Or we may write I1P plus IgG must be equal to I minus I1 whole into R. This is equation number 1. Similarly in the loop, that is BCDB, that is here only I1 minus Ig flowing is clockwise, but Ig and this Ig plus I minus I1 in the anti-clockwise. That's why we are writing here 0, because no potential is applied across the loop. So we are writing here I1 minus Ig into across the resistor Q minus Ig across the resistor galvanometer G minus what? Ig plus I minus I1 across the resistor S. Okay, that implies we may write I1 minus Ig whole into Q is equal to what we are getting? IgG minus Ig plus I minus I1 whole into S. This is equation number 2. This is the point. Up to this point we are getting equation 1 and 2. The important point is that the resistor S, that is variable, is so adjusted that the potential of B must be equal to potential of B. That means by adjusting the resistance S, we have to take a condition at which the potential of B must be equal to potential of D. That means what happens? As the potential B and D are equal, then no current flowing across the galvanometer. That means the value of Ig equal to 0. Putting these values in equation 1 and 2. Now putting these value in equation 1 and 2. What we are getting? Then if we are putting Ig equal to 0, this term will be 0, and we are getting what? I1P is equal to I minus I1 whole into R. Similarly in equation T, if we are putting here Ig equal to 0, we are writing here I1P EU is equal to this term equal to 0, and this term must be equal to 0. This term must be equal to here. Actually we are putting a wrong sign, that is must be positive, because this side go and this side go, that's positive. So Ig taken as 0, that means we are writing here I minus I1 into S. This is equation 3 and this is equation 4. If we are dividing these two equations, what we are getting? I1 cancel, I minus I1 cancel. That implies P upon Q is equal to R upon S. This is called balanced condition of Wheatstone Bridge. As R is the unknown, using this we are writing here R is equal to PS upon Q. That means using Kirchhoff's law, we are know the construction, working and theory, and this is the conclusion part. This is the balanced condition of Wheatstone Bridge. Sometimes the question arises derive the balanced condition, and sometimes the question arises find the resistance of unknown resistor. So if question arises is the balanced condition, and this is the balanced condition we already derive. If we question comes that to derive the unknown resistance, then we can write R is equal to PS upon Q. Okay, this is all about your working, construction, theory and derivation of Wheatstone Bridge. Thank you all for watching. If you want to know more about the different long questions, that important long questions for annual CHSE exam, then subscribe my channel and follow my channel. Thank you all.